Today we're going to talk about piecewise functions. And what you can't see on my screen just yet, but you can see on your paper, is that the following graph is called a piecewise function. And the reason that it's called a piecewise function is because the function is defined by two or more different equations applied to different parts of the function's domain, which probably doesn't mean that much to you when I read it out loud. But if we look at the picture here, what we've got in our picture is we've got parts of a graph. So we have a part over here to the far left. And we have a part here in the middle of the graph. And we have another part to the far right of the graph. And so what I say is, notice that this graph is composed of three parts or pieces. And what we've done is we've drawn lines over a specific domain. So we need to go back and remind you about domain for a couple minutes. Remember that domain is dealing with the x values of the function. And so we're looking at a graph from left to right. So if we look at, for part one here, what is the domain for the left segment? What we're going to do is we're going to look farthest to the left. And our value farthest to the left, our x value of that point, farthest to the left, is -6. And the x value of the same segment that we're looking at, this first piece, the x value over here is -3. At -6, this circle is filled in. And at -3, the circle is not filled in. So it's going to have filled in means included, so we have a bracket. And open circle means we're going to have a parentheses. Now that's what we did. We talked about interval notation when we were dealing with domain earlier in the year. But typically for piecewise functions, the way that our domain is going to be written is going to be -6 is less than or equal to x is less than -3. But I want to refresh our memories on the domain and also the range here, so that we can then apply it when we're working with the rest of our notes. The range deals with the y values, and the y values are the lowest value to the highest value, and those are y's. The lowest y value to the highest y value. So our lowest y value in our segment to the far left is 1. And our highest value in the segment to the left is 4. And once again, at 1 we have a filled in circle. But at 4 we have an open circle. There's our interval notation. And we could have also written it as 1 is less than or equal to y is less than 4. Remember, domain are the x values, range are the y values. And that's our left segment. When we look at the middle piece, what's the domain for the middle? The middle segment. Domain. Far left. Well, our far left is going to be the x value to the far left, which is -3. And far right is going to be 4. And both our endpoints are filled in this case. So we're going to have square brackets around both. But again, typically we don't write domain in this notation for piecewise functions. we write it as negative 3 is less than or equal to x is less than or equal to 4. When we look at the range are the y values on this function. And in interval notation, what we simply need to notice is every single y value on this middle piece is the same. 2, 2, 2, 2, 2, 2, 2. Every single y value in that middle piece, which is a horizontal line segment, is 2. So in interval notation, we can just write it as 2 to 2, a little bit weird. Or we can write 2 is less than or equal to y is less than or equal to 2. Which leaves us with the third segment, and that's going to be to the far right. Our domain are the x values. So farthest to the left here is going to be 4. Farthest to the right is going to be the 8. And both of these have open circles, so this is going to be parentheses. But really, in terms of our domain for these types of functions, we write it in our set notation, which is the 4 is less than x, which is less than 8. And our range. Our range is going to be the lowest value on this graph to the highest value on the graph. And you do want to go lowest to highest. And our lowest value on the graph is at this point 8, negative 2. So it's going to be negative 2. Our highest value on this graph is up here at 6. And again, this can be 2 is less than, negative 2 is less than, y is less than 6. So hoping that that's a little bit of review there. But our piecewise functions have parts. So let's take a look at our second one here. It says use the piecewise function to the right to answer the following questions. How many equations do you think you'd have to write the rule for piecewise functions? And you can show me on your fingers. How many do you think? 2. 1, 2. Notice, and then give it away in the next part. Notice that it appears to be composed of 2 pieces or parts, each a different linear function over a particular domain. So now what we want to do is we want to come up for the domain of this left ray, and I need to digress for a minute to remind you the definition of ray that you used in geometry. And what the definition of ray is it has a starting point, but then it continues on in one direction forever. So we start with our left ray, we start here at 3, 1, and we continue in the kind of left-hand direction forever and ever. Or in our right-hand ray, we start here at 3, 4, and we continue towards the right forever and ever and ever. So what is our domain for our left ray? We can say that it is x is less than 3. And the range of that ray is from the lowest value, so we can say that it's going to be y is greater than 1. I did not put equals in there because they're open circles at 3, 1. If we look at the second ray, the ray to the right, again, it has a starting point and it continues on towards the right. And in this case here, the domain for the right ray is that we start at 3, but it's filled in circle. So it's going to be 3, and then everything beyond 3 towards the right. X is greater than or equal to 3 is how we read that. The range, the lowest value, the y value of that point, 3, 4 is 4. So this is going to be y is greater than or equal to 4. Again, the equal because there is a filled in circle on that graph. Now, as we move on here to our next page, now what we're going to try to learn how to do is we're going to try to learn how to graph a piecewise function. And so here is an equation. The following notation can be used to describe a piecewise function over the function's domain. So we've got f of x equals 2x when x is between -5 and 2, and f of x equals 5 when x is between 2 and 6. And what we're going to do is we're going to make a table here. And we're going to fill in some values here to draw our picture. And the first part says, use the points below to graph the first equation. So our first equation is up here at 2x. And what we're going to do, we're going to put -5 back into our function for 2x, and we're going to replace that x with -5. And then we're going to do the same thing, replacing x with -3. Replace the x with 0. So in terms of work here, this is going to be 2 times -5. And maybe you don't even need to show that, but that gives us -10. I'm going to put -3 back in here for the first equation, which is 2x. 2 times -3, which is -6. Put 0 back into the equation for x. 2 times 0 is 0. Put 1 back into the equation for x, and we get 2 times 1 is 2. And put 2 back into the equation for x, and we get 2 times 2 is 4. And let's go ahead and graph that right now. I know we still have another piece, another part to deal with, but let's graph. -5, -10. -3, -6. 0, 0. 1, 2. And 2, 4. Those are the only values here. We have a starting point and we have an ending point. Do the best you can to draw freehand like I just did. Hopefully you're better than me. But there's one more thing that we need to deal with on this problem here. Because if we go back and we look at our domain, which says -5 is less than or equal to x is less than 2, at the point -5, we're going to have our filled in circle. But when we come over here and x is 2, this is going to be an open circle, because there's no equals with the 2. And I know that we already have it graphed there on our paper. What I usually do is I just put an open circle around it. So if you don't want to erase that point, just put a big open circle around it. And again, the reason that it's open is because it says x is less than 2. It doesn't have an equals in there. And there's our first piece of our function. Now we're going to draw our second piece. We've got the value 2 and 3 and 4 and 6. We're going to use those values back into our function. But there's no variable up here with our second equation, which is 5. So that means when we put 2 back into our function, our second equation, we get 5. When we put 3 back into our second equation, we get 5. And when we put 4 back into our second equation, we get 5. And when we put 6 back into our second equation, we get 5. We don't have a variable to put back in there. So no matter what value we pick, every single time we're going to get out of that function of 5. So we come over here and we're going to graph 2, 5, 3, 5, 4, 5, and 6, 5. That's the only place that we're graphing, is everything in between those two. As you're graphing those points on your paper, think about, do we need to put an open circle on either one of those endpoints? And the answer is no, because it says 2 is less than or equal to x is less than or equal to 6. Both at 2 and at 6, we've got an equal sign. We do not need to put in any open circles. And now we've got our picture. 2 pieces. So there's part A here. We've got a couple more questions to answer. And the second question is, how many pieces does our graph have? Well, we've got 2. And what's our reason why? Well, we had 2 equations. Are these pieces rays or segments? And they're segments. And the reason is, and I'll keep it short, is because there's a starting point and an ending point. That is not a complete sentence, by the way. But I want to keep this short. Are all the points solid dots or open dots or some of each? Well, we've got everything graphed, and as we flip back and we look at it, it's some of each. And I'm going to put comma because there is an open dot. It's going to be hard for me to squeeze in at. In our order pair, there's an open dot at 2, 4. Again, you can't read that. Sum of each, because there is an open dot. Wonder if that'll be any better. Ooh, haha, we don't like that. And I can't undo. That's even worse. Back. Oh, no. Is it undo button? This one? It doesn't work. See how it's kind of blanked out? I wonder if edit. Ah. Undo. Let's try that. Undo recognize. Ah. Okay. Tried. Doesn't like it. Sum of each, because there's an open dot at 2, 4. Were all of these x values necessary to graph the piecewise function? Or could this have been graphed using less points? Well, we could have graphed using less points. Which ones were critical? Well, the ones that were critical are the endpoints. So what did I put? Endpoints from each domain. As you write that down, I want to pop back to the equation again because I want to show you what I'm talking about if you don't know what that vocab means. The endpoints from both domains. We want to put in -5. And we want to put in 2. We want to put in +2 and 6. Those are the most critical. I personally like to put something in the middle. I like to put it in between. But if you want to get technical, 2 points determine a line. But can you generalize which x values are essential to input into your table to make a hand sketch graph? Well, same answer here. The endpoints from each domain. So let's try another one. That's the first one that we've ever graphed. Let's see if we can shorten it up a little bit here. It says now we're going to graph this piecewise function. F of x equals x plus 3, and we have our domain of -8 is less than or equal to x is less than 1. And 10 minus 2x is our other equation, and our domain is 1 is less than or equal to x is less than or equal to 7. Well, if we use our idea of what we were just answering here, which x values are critical? The endpoints from each domain. So let's graph -8 and 1. Let's find those values. And then in between here, I'm just going to blank that out to separate it. Then in our next ones, let's graph 1 and 7. So my spacing is a little bit tough here. And I'm going to write it over here in the graph and then I'm going to erase it. But to figure out this value, we're going to take -8, we're going to put it back into x plus 3 for the x. So this is going to be -8 plus 3, which is -5. We're going to put 1 back into that first piece. So it's going to be 1 plus 3, which is 4. And I'm going to erase that. But I wanted to show you where that came from. We put those values back into the x of our first equation. And now let's go over here and graph. -8, -5. 1, 4. And there's our first piece. Once we get this graphed, we need to think about, do we need open circles anywhere on that segment? And already we're getting nods of yes, because we have a place where there's not an equal. There's not an equal at 1, so our point at 1 is going to have an open circle. But now we've got that. When we go to do our next part here, I'm going to write it off to the left instead of the right, but it's going to be 10 minus 2 times 1. putting the 1 back into our second equation for x. So 10 minus 2 is 8. And 10 minus 2 times 7 is 10 minus 14, which is -4. And use your calculator if you need to come up with those values. But once we come up with them, it's 1, 8, and it's 7, -4. And hopefully your picture looks a little bit better than mine. But why did we choose those x values that we put in our table? We chose them because they were the endpoints. Of our domain. We graphed the order pairs from the table and we sketched our function. How many pieces do we have? Well, once again, we have 2 pieces because we have 2 equations. Are they segments or are they rays? Well, they're segments. And they're segments because we have a starting point and an ending point. Was it necessary to evaluate both pieces of the function at x equals 1? Yes. 1 is in both domains. One is in both domains. I want to scroll back up here for a minute to look at the problem again. But it's -8 is less than or equal to x is less than 1. And then it's 1 is less than or equal to x is less than or equal to 7. So there's the 1 in both parts of the domain. And last question on this one. Which x values were critical to include in order to graph the piecewise function? Well, the values in the domain. I don't know how to say it different. Because they are the starting point. I'm going to put plural, starting points. And ending points. One more graph to take a look at here. Just going to be a slight bit different, but the process is still the same. And the difference, as we take a quick look at this, is that we have x is less than 4, and we have x is greater than or equal to 4. If we skip down here to question number 2 real quick, it says, are the pieces of your graphs segments or rays? This one's going to be rays. because we have starting point but no ending point. We have a starting point, but we don't have an ending point. So when we look at this picture here, when we go back to graph it, the first value that I'm going to do for the first equation is 4. But then when we look at our domain, we have to pick a value that's less than 4. Any particular value that you would like to pick that's less than 4, and it doesn't really matter to me. Somebody said 1. I actually picked 0. But you just want to pick another value, because remember, 2 points determine a line. Then I'm going to X out this box because we're going to do the second equation. And once again, we need to do 4. And then we need to pick a value that's bigger than 4. X is greater than or equal to 4. So there's the 4. What point would you like to use? What'd you say? 7. Just something greater. I used 10. So we're going to fill those back in. And I think I can squeeze this in. It's going to be 2, wrong color, but 2 times 4 minus 5. 2 times 4 is 8, minus 5 is 3. And 2 times 1 minus 5. 2 times 1 is 2, minus 5 is negative 3. Remember, in this particular graph, we're not going to stop. It's all the values for the domain, in the domain, that are less than 4. So we graph 4, 3, and then we graph 1, negative 3. And on this one, we're going to continue the graph because it's array. As we put those values in, we need to ask ourselves, do we need an open circle on this? And the answer is yes. It says x is less than 4. There's no equal there. So we're going to put an open circle right there. And then we're going to do the 4 and the 7. But when we put 4 back into our second equation, we don't have an x. We're going to get negative 6. When we put 7 back into that equation, we're still going to get negative 6. When we come over here and graph 4, negative 6. 7, negative 6. But once again, like the first piece, the second piece doesn't stop. X is greater than or equal to 4. All of the values greater than or equal to 4. And we need to ask ourselves on this part as well. Do we need to put an open circle in on this one? And it says greater than or equal to. So we do not. So as you can see, how did we choose the x values to go in our table? We picked an endpoint. And one other value. Down here at the last, if you were only given one endpoint, how do you know the way to graph the rest of the line? Well, we pick another point and we put an arrow on, let's say, on that line. And actually, I'm going to say on that ray. Pick another point, and we put an arrow on that ray.